Hello, welcome again to P&G Custom Woodworks. It's been a while, but I thought it's time that perhaps I should give you a little brief update on what's happening here in the shop. And unfortunately, it's time to say goodbye. No, I'm not leaving, but my old trusty router is. It's time to upgrade. The router has served me well since 2014, but somebody else feels that they need it more than I do, and I'm going to let it go and replace it with a hopefully new and improved version. The frame is already built, and once I remove this from the shop, I'll be bringing the new frame in, all steel welded frame, by the way. The shop is small enough that I can't bring that in until this is removed. So the first step is to remove the old router from the shop, bring the new router in, router base in, and from there I'll let you join me in the build, and we'll see where it goes. I think it's going to be a fun project, and on with the work. Let's get with it. Here it goes on its journey to the new owner. It's the last time I'll see it, but it's out of the shop, and now I can make room for the new one. This is it, Big Blue. The weldment itself is all fabbed from 11 gauge box tubing, the legs being 4x4, the Y rails are 2x6s, the bed bracing is 2x2, and the lower leg stiffeners are 1x1. The weldment, as you see it right now, is heavy, but it's not so heavy that two people can't manage it. However, I have included 2-inch casters on it with leveling feet, and once the unit is placed into final position, I'll bring the levelers down, take the weight off the casters, hopefully eliminating any flat spotting. And as much as I would like to admit it, I had to have the frame welded up at the local shop. I'm not a welder, nor do I have the equipment. And if I were to weld, at least attempt to weld, my welds would look something like this. And in reality, I was looking for a weld that looked like this one here. We have talked at detail about what's going on with the new router frame. I'd like to take a moment to discuss some of the pieces and parts that I'll be using for the build on this project. The linear guide rails are 20 millimeters. You'll notice, I hope if you have a keen eye, you'll notice that they look a little long, and that's because they are. And the reason for that is because I can buy them long, trim them to length, and save a little bit of money. So you buy more, pay less. Go figure. That doesn't happen too often. And the same thing with the 16 millimeter ball screws. I'll be able to trim those down to length, saving additional monies there. So 20 millimeter linear guide rails, 16 millimeter ball screws on all the axes with the exception of the Z axis, and the Z axis is 20 millimeters. The reason for that being, I feel that I can make the system a little bit more rigid, thereby allowing me to move the machine a little faster, take some heavier cuts. That's the thought philosophy behind that, at least, and hopefully that works. So we have the guide rails, the screws, all of the supporting bearings for the rails and the screws. Here by x-axis I have a 160 by 80 extruded aluminum rail. I was taken, and it's 52 inches long. I was taken back by how much the thing actually weighs. It's 34 pounds. who says aluminum is light? So I guess if you pack enough aluminum into a spot, it does eventually get heavy. But 34 pounds was heavier than I expected, but it should give me a rigid base for the X-axis. For the drive motors on this machine, I will be using NEMA 24s instead of 23s, which I used on the old machine. And I'm thinking that with the 24s, with the 10 millimeter shaft on it, the motor itself will be a little more, a little stouter. It'll allow me to move the machine a little faster. And again, I shouldn't be worried about stalling or snapping anything off. By the way, I have already snapped the shafts off on NEMA 23s. I don't know, I think it was probably a faulty shaft, but I did have one that snapped off on me. And I really don't want to do that again, nor do I want to experience it. The spindle on this, on my new router, will be 2.2 kilowatt. It'll be air cooled. The reason for going with an air cooled spindle instead of water cooled is simply my preference. I didn't want to deal with the plumbing on the water cooled system with the cooling tank and possibly having to run a chiller for the cooling to maintain temperature. The associated spindle mount I have on hand here. Power supplies for the system will be dual 48 volt. Let's see, what is my amperage on that? Looks like I'm out there at 8.3 amps. So I'm going to be running dual 8.3 amp power supplies, one power supply for two motors. Should be more than sufficient to drive these things where I don't have to worry about starving them. That will drive into 4 Separon line DM556T drivers, digital drivers, real fine drivers. They're more than capable of handling the voltage and the current that I'll be sending through them. No problem at all. The control board that I'm going to use, I opted to use this time, is an EC300 ETH. That's combined with a C94 breakout, allowing ample breakouts for any switches that I may desire, limit switches, home switches, e-stop, any relays that I may put on it if I want to put a misting or an air system onto it. It should allow ample space to do that. My old system did not give me that flexibility. So that, in a nutshell, is the pieces and parts that I'll be using. I invite you to join me as we move forward with the build. You'll see how I fabricate some of the pieces and parts, how I assemble them, and ultimately first run. So again, please join me, and it's going to be a fun build. Have a good day.